This is the first part of three parts video on consolidation and settlement. The first part will be the consequences of soil settlement. The topic for this time will be consolidation and settlement and its effect on constructed facilities. Okay, this is how consolidation could affect constructed facilities. Of course, on top, I think you have seen this before. You can see this gap here from the wall. This is the grass here. It was originally at this level, right? It was originally at this level here. The grass was here. Now it is already dropped down about 200 mm below. So that is because of the settlement, and then it exposed this portion here. And of course, this is a very famous building here. Everyone in soil or geotechnical engineering would know this. But interestingly, this leaning tower of Pisa, we also in Malaysia, we also have one version of of the leaning tower, which is this one here. If you notice, this is in the state of Perak. It's actually in Teluk Intan. Perak now has become also become tourist attraction because of a similar leaning tower like the Pisa here, okay, in Italy. Okay, also if you look at this one here on the photo on the right, you can see the settlement. In this case, the base settlement takes place that caused this what do you call it, retaining wall here. This is retaining wall actually to collapse. You see it on this crack and it collapsed down because of the settlement below. So this is some issues. How consolidation and settlement can affect our facilities, our buildings, our infrastructure, and so on. And of course, this settlement will usually happen in area with a Menara Condong. Yeah, and this settlement usually happen in area with a soft soil, with a clay type of soil mostly. And we, if possible, we want to avoid this area. But of course, these days, like I'm showing here, we have sometimes we have no option. We still need to reclaim the area with the what do you call, with the lower strength, with lower capacity, bearing capacity soil, because you look at this illustration here, this what do you call, the easy part of the land or the good stable landform has already been occupied by buildings. So we have no choice. We have either we go up the hill or we go towards the sea, even though the soil is not good in this area. So you go, let me see, you go towards the sea or you go towards the hill, right? Sorry. So so both location, either towards the coastal area or towards the hillside, they have their own geotechnical challenges. If you go towards the sea, the issues are more about soft soil settlement, and also saltwater intrusion that can cause your structures to deteriorate and so on. If you and also issue of water movement in soil that can cause flooding, things like that. If you go up the hill, you have geotechnical issues such as landslide, slope stability, and sometimes you have problem with the water supply because you are way too high and you have water pressure, things like that. So they have different set of problems, but all this problem, of course, with the people like us in the technical area, we can find a solution to overcome the issues of either going to the low-lying area or the hilly area, because the usual what do you call it, suitable area has been occupied. So we have no choice. You have to go away from the usual place that we construct building. So you have to go uphill or towards the sea. So this is the issue with. But today we are going to talk about the issue with basically soft soil, or the issue of settlement and consolidation. Of course, we have seen this before. If we go towards this a low-lying area where there are swampy area, these are the issues. You know, even the machine can be swallowed by the soil, and we have a flooding issue like this at the bottom here. We have subsidence like this one here, and landslide that can cause collapse to buildings. So this is the situation that we will face. And in other situation, in the low-lying area, towards the coastal area, we usually have what we call a settlement or consolidation that cause a lot of inconvenience. In this case, for example, for the road infrastructure, for example, in this case, you are driving on a bridge, you are jumping up and down because of the bridge is sitting on a piling system, but the remaining, for example, the remaining soil here is sitting on the ground. This ground at the bottom here will settle, and then there will be a gap here. That's why when you drive in a coastal area or low-lying area, chances are you will experience some of this bumpy ride. And you are driving like what happened to this car. But I hope no one will have this. No one will have to to jump down the bridge like that. But there was a lot of inconvenience up until now. This problem cannot be 100% solved. What usually being done is we will top up this once there are some settlement. What we will do usually, we will try to top up again this area so that there will be a smooth transition. But the more you top up, the heavier this area will become, and then there will be more settlement. So the settlement will keep on going if you keep adding up more covers up here. So that is the situation. So these are the issues of the settlement and consolidation. So let us now go to a little bit on the what do you call it? The process that can cause settlement. Three common physical processes that produce settlement in soil. Okay? First, this is what we call consolidation settlement, right, of the soil. They all sometimes is called primary consolidation. The second is Okay, Noor is going to Salat. Okay. The second will be what we call secondary compression. Secondary compression settlement that is resulting from particle orientation or adjustment. Okay, that's called secondary compression. And the third one is distortion settlement or lateral movement of the soil. But 90% of the time, 90% of the time, and 90% of the settlement come from number one, which is the consolidation settlement. The secondary compression, that one will be a little or can happen very quick, especially if you are talking about sand. And distortion settlement is it depends on how the loading is being applied to the soil. But most of the time, 90% of the time, the primary consolidation is the one that produces the major portion of the settlement problem or the consolidation extent. That is why usually once we have detected that the consolidation has taken place up to 90%, then we will continue with the project. That means we expect just a little bit more settlement that will not cause problems to our project. That's what is usually being decided in the field. Just to recall again the difference between consolidation and compaction. Remember last week we talked about compaction, and this time we talk about consolidation. Consolidation is we try to remove water. Remember, we try to remove water from the soil. From the soil. Okay. Compaction we remove air. All right. Okay. So that's the difference. That is why in the low-lying area there are always the soil is always underwater, or there will be a higher moisture content. So what will happen is that once we remove the water from the soil, it will the volume will be smaller, but at the same time it will also become stronger because of the consolidation. Distortion settlement is a lateral, like I said before, lateral deformation take place when heavy loads are applied over small area. This is the distortion settlement. This is usually issues to individual structure or building. But when you talk about overall settlement, we're talking about large area of settlement that is caused by the primary consolidation. This is an example of settlement, but in this case is because of distortion. You can see this building is there is a different level of settlement here. On the right, it is still there, but on the close left, this column here has settled into the soil. So this is because of the ability of the soil below here is probably weaker than the other side here. So that is also called differential settlement. So there is another issue. Okay, like I said before, the primary consolidation is the one that usually creates what we call the majority or major portion of the total settlement, or 90%. So the primary consolidation is a phenomenon that occurs in happen for both sand and clay. Also, can only be isolated as a separate phenomena in clays. Because in sand, it can happen quickly. It will not take a longer time. So what will happen is expulsion of water from soil accompanied by increase in effective stress and strain. If you say is consolidation or settlement is good or bad, it is good if the consolidation or settlement has already taken place when you start the project. It's going to be bad if you start your project before the settlement and consolidation takes place. It will cause collapse or crack your building. But if they are already, you let them consolidate first, then you start your building, then you'll be okay. That's why what we do in the field. If we foresee that the soil will settle under the building that we are proposing, that we propose to build or building or road or whatever structure, we want them to be consolidated first. We want them we want the settlement to take place before we start our project. The amount of consolidation or settlement can be estimated. So this is when we estimated the settlement that will happen in the lab. Then we would know later on in the field when we can go into to start the building construction. Let's say we expect the settlement to be 1 meter. So once we have got 90% of the settlement, for example, so in this case 900 mm, then that means it is safe to start constructing the building or road in that location. But we have another issue. The rate cannot be estimated very accurately in the lab. The rate means how long it will take. That is the issue. The rate we cannot estimate properly, but we know what is the maximum settlement that will happen. We can estimate in the lab quite good in the lab. So at least we know how much the soil will settle. When we take the sample from the site and bring to the lab, and we test in the lab, and then we know how much settlement will take place based on the proposed loading. If you have 2-story building, of course, we'll have different settlement than 3-story building, different settlement than 4-story building. So it depends on the loading that you are going to put on that location. Okay. So we will, let's say you want to construct 4-story building. So we will test the lab in the lab to see what will be the total settlement if there will be a 4-story building on that site. So now we know what will be the settlement. Then we will go to the site. We'll make sure the soil settle to that amount first before we go and construct the building. And then the building will not cause any more settlement because the soil has already settled to the level that is going to be to be affected by the total load on the building. Meaning basically something like you generate. You create the settlement has generated certain strength to handle the loading from the building. So that's why we want them to settle first before we put the building on site. Partially recoverable means they are not elastic. That means once you have compressed them, it will not come back. All right. That's why it says partially recoverable. So this is another illustration of issues of settlement. You can see crack here. Okay, you see the cracks because of settlement around here. Of course, you can see this the difference between these two portion of structure here. One is slightly higher than this one. Originally, they are the same level. Originally, they are. This one is the same. Now one coming down, one not going up, but one is higher than the other one. This happened because this portion here is sitting on the ground, but this portion here, including the building here, is sitting on the pile. Pile transfer the loading to the stronger soil, but this portion here is not sitting on the pile. They are just a small structure connecting footbridge to this building here. At the same time, you can also see this marking down here. There is already soil settlement. The soil settled. Now that means that this structure has moved down. Not only the soil moved down, the structure also go down together with the soil. But of course, with the different amount, you can see the soil drop more than the structure. So this is what happened when we do not make sure the settlement or consolidation takes place before we go and have this structure at this place. See, also again here to show the difference here. The difference here. So the difference, there will be a different settlement because of settlement, right? So these kind of issues can be solved if you make sure the soil settles first. But of course, it depends on the type of soil for us to know how long and how much time it needs. We need to make sure they settle first. So if you look below the ground, if you have a ground slab, floor, once the soil below has settled, there will be no more support from the soil to your slab. So you can see down here is a void underneath ground floor slab in this case. And then you can see the void here. And then, of course, I don't know, some people may like the void. You can put some money inside there or something like that to hide something inside. Is that below your floor? But it's not good because sometimes dangerous animal can go slide around below your slab, which is not good. Okay, again, this is just to show this. See, this is gap here. You can see the gap because of the. You can see the gap or more gap here because of settlement. See this building here. This building, they are on pile, so they don't go down. But this soil and drain here, they are on their own on the soil. So when the soil settles, everything will go down. So it creates the gap. It creates the gap here, and then of course it is not a matter of structural integrity, but it will cause other problems. The structure will not fail, but the gaps like this will cause snake to stay inside here, for example, or rats to multiply, things like that. Of course, when there are rats, there will be snake. So you don't want that to happen. Okay, and now a little bit on secondary compression. Like I said before, this is the adjustment of the material. No pressure change. Only after completion of primary consolidation. It can happen fast if the material is sand, but it will wait a lot more time if the material is clay, because it requires the primary consolidation to take place first. And primary consolidation for sand can be very quick, but for clay it will take very long.